Here is a bag of flour, 50 pounds. Now imagine you have 1,000 of those bags and you need to ship them from Shanghai to Lanzhou, a city in northwestern China, about 1,200 miles away. By truck, that'll cost you roughly $2,400. Now take that same flour and ship it from Shanghai all the way to Buenos Aires, Argentina, 10 times the distance across an entire ocean. The cost? Around $1,900. And that's after a significant spike in global shipping rates in recent years. 10 times the distance. Lower price. So what made it possible to move goods across the planet for less than it costs across a single country? The answer is hiding in plain sight. Something you've seen your whole life but probably never thought twice about. Today, we're talking about the shipping container. A buyer places an order. A seller packs the goods, loads them onto a truck, and hauls them to a port. At the port, a crane lifts a steel box onto a cargo ship. The ship crosses an ocean. At the destination port, another crane lifts the box off the ship and directly onto a train. The train runs through the night. A truck picks it up and drives the final miles to the buyer's door. It feels seamless, almost obvious, like it was always meant to work this way. But here's the thing, why does it work this way? Why, in a world where we can't even agree on a universal phone charger, do cargo trucks, ocean freighters, and freight trains from completely different countries all work with the exact same steel box? To answer that, we need to go back to April 26, 1956. On that day, at the port of Newark in New Jersey, 58 aluminum truck bodies were loaded onto an old oil tanker called the Ideal X. The crew had no idea they were about to complete the first containerized shipping voyage in history. The man behind it was Malcolm McLean, a trucking mogul and one of America's classic self-made success stories. McLean came of age during the Great Depression. At 21 in 1934, he founded the McLean Trucking Company with a single-use dump truck and essentially nothing else. Over the next 2 decades, he built it from scratch into one of the top 3 most profitable trucking firms in the country, 617 trucks, a net worth of $11.4 million, all built from zero. By 1953, McLean was running one of the largest trucking operations in the country, but he was worried. Roads were getting more congested every year. Every minute a truck sat in traffic was money left on the table. One day, passing by a port, a thought hit him. If the roads are jammed, why not drive the truck straight onto a ship and go by sea? Once the idea took hold, he kept refining it. He realized he didn't even need to ship the whole truck, just the cargo trailer on the back. The cab could turn around and make another run. The cost advantages were obvious. And since his company was based in North Carolina right on the East Coast, ports were already nearby. There was also a convenient tailwind. After World War II, the US government had a massive surplus of military cargo ships. A new law allowed American shipping companies to buy or lease them at rock-bottom prices. McLean wanted those ships, so he bought a shipping company to take advantage of the deal. While waiting for the acquisition to go through, he realized that putting wheeled trailers directly on a ship was a problem. The wheels took up too much space and the trailers could slide around. So he went further, strip away the wheels entirely, keep just the box, and build it to stack neatly in a ship's hold. The concept of the modern shipping container was born. But before it could change the world, one very practical question needed an answer. How big should the box be? To figure out the dimensions, McLean tracked down Keith Tantlinger, chief engineer at Brown Industries. As it turned out, Tantlinger had already independently invented something very similar. A 30-foot aluminum container that could be stacked too high on a barge or hauled by truck. It was almost exactly what McLean had in mind. His only request? Make it 33 feet instead. No deep engineering reason. He just needed 33-foot boxes to fill his specific ships as efficiently as possible. Later, when he got bigger ships, he switched to 35 feet. Around the same time, another major shipping company, Matson Navigation, was getting interested in containers. They hired a geophysicist, someone who had worked on the Polaris nuclear submarine program, to run the numbers. He ran thousands of computer simulations, which was a seriously expensive undertaking at the time, and concluded that 24-foot containers were the optimal size for Matson's routes. Oh, and while he was at it, he also published an academic paper on his findings. A smaller company called Grace Line, which operated in South America, settled on 17 feet to handle the winding mountain roads of the Andes. By 1959, over 58,000 containers were in use across the United States, in a dizzying variety of shapes and sizes. It was chaos. And people started asking, do we need a standard? The American Standards Association's MH5 committee was tasked with sorting it out. The challenge was enormous. Every company had already invested heavily in their own container sizes. Switching to someone else's standard meant writing off massive sunk costs. Nobody was going to budge willingly. The committee's solution was almost elegantly absurd. Instead of choosing among the existing sizes, they threw them all out and proposed 4 entirely new ones: 10, 20, 30, and 40 feet. Now, you might be wondering, was there some deep engineering logic behind choosing those 4 numbers? Nope, not really. Why those numbers? The committee chair, a retired aluminum industry engineer named Herbert Hall, admitted he didn't know much about shipping economics. He picked those dimensions because, as an engineer, he liked how neatly they scaled. Each size a simple multiple of 10, they could nest like Russian dolls. Was it rigorous? Not really. But coming from a man working in feet and inches, maybe we shouldn't expect the math to be elegant. Anyway, back to containers. These 4 sizes became the American standard in 1961. Within a few years, the ISO, the International Organization for Standardization, adopted them globally. The shipping container finally had a universal spec. From the first voyage in 1956 to the American standard in 1961, 5 years had passed, and containers were still a niche technology. Only 2 US shipping companies used them at scale, and only at a handful of domestic ports. The reason was simple: containerized shipping isn't just about the box. It requires an entire ecosystem: purpose-built cranes, reinforced docks, compatible trucks and rail cars, and the infrastructure to connect them all. When McLean launched the Ideal X in 1956, he had to dismantle and reinstall a custom crane just to load 58 containers. The destination port needed one too, and many ports at the time were built of wood. They couldn't support the weight of industrial crane equipment at all. On top of the engineering challenges, there was a political one: dock workers. Let's be direct. The whole point of the container was to eliminate most of the labor involved in loading and unloading ships. Longshoremen who had spent their careers manually hauling cargo understood exactly what was happening. With help from their unions, dock workers across the country organized to resist the spread of container technology. High upfront costs, constant threat of labor action. At this rate, containers might have stayed a footnote in transportation history. Then came Vietnam. By 1965, the US military was deep in Southeast Asia and struggling with a logistical nightmare. Traditional supply ships needed 10 to 30 days for a round trip. And even after a ship reached port, unloading the cargo took another 8 days. The military convened a meeting of the country's top shipping executives and asked a blunt question: how do we fix this? McLean stood up. He had an answer. The 2 obstacles that had held containers back for a decade, the cost of infrastructure and the resistance of labor, meant nothing in the face of the state. In 1966, driven by urgent demands from soldiers on the front lines, the military awarded the contract to McLean's own shipping company, Sealand, and construction of a dedicated container terminal in Vietnam moved fast. On August 1, 1967, the first fully loaded container ship sailed into Da Nang Harbor. The ship, the Bienville, carried 226 containers. All of them were unloaded in 15 hours. Remember, that same job had taken 8 days before, and it wasn't just fast. Containers stacked neatly in a ship's hold, maximizing every cubic foot of cargo space. According to post-war military analysis, 7 container ships could carry the same load as 20 conventional freighters. The savings weren't just in time either. The US Army's Deputy Chief of Staff for Logistics later stated that if containers had been used from the very beginning of the war, the military would have saved at least $882 million. The world was paying attention. After Vietnam, adoption accelerated fast. In 1965, container shipping was still considered experimental. By 1968, US ports were processing 3,400 containers every week. Ports in Rotterdam, Bremen, Antwerp, Glasgow, Montreal, and Yokohama raced to build modern container terminals. And today, the 20-foot container, called a TEU or 20-foot equivalent unit, has become the base unit of global trade. Chinese factories manufactured more than 8.1 million TEUs worth of new containers in 2024. Everything in modern logistics is built around this box. Large container ships are fitted with vertical cell guides, metal rails precisely spaced to fit 20 or 40-foot containers. Port cranes use telescoping spreader bars designed to lock onto the corner fittings of those exact sizes. The standard flatbed truck trailer is built to carry exactly one 40-foot container or 2 20-foot containers side by side. Railway flat cars have the same locking fittings. The box came first. Everything else was built to match it. According to United Nations Conference on Trade and Development, global seaborne trade reached 12.29 billion tons in 2023. The same year, the world's container ports handled roughly 858 million TEUs. In the time it took you to hear me read that number, ports around the world had already processed over 100 standard containers. The cost of running this entire global system for a year? Under $500 billion, which works out to about $41 per ton of cargo. To put that in perspective, in 1962, shipping steel pipes from New York to Brazil cost $57 per ton, and that represented 13% of the total cost of the product. It's not a perfect apples-to-apples comparison, but the direction is unmistakable. Back in 1962, the US dollar was still directly pegged to gold, $35 to the ounce. Measured against gold prices, that $57 is roughly equivalent to $5,300 today, though measured by CPY, the figure is closer to $600. Either way, the direction is unmistakable. Shipping costs have collapsed, from thousands of dollars to $41. In 67 years, the cost of moving goods around the world fell by over 90%, and by some measures, closer to 99%. When something gets 10% cheaper, it's a footnote. When it gets 90+% cheaper, it changes how the world works. Transportation costs became essentially negligible, and once transportation costs disappear, offshoring manufacturing becomes viable. The car you drive was probably assembled using parts from 20 or more countries. Body panels, electronics, safety systems, engines, transmissions, sourced from the US, China, Japan, Germany, Sweden, Indonesia, and beyond. This is what made globalization possible. Globalization is what lets a wholesale market in Yiwu supply every Walmart in America. It's what puts Argentine beef on your dinner table. It's what lets Boeing source aircraft components from around the planet instead of building everything locally. Here's what makes the container story so remarkable. It didn't invent any new technology. No new materials, no new physics, no breakthrough engineering. It just established a common standard and let the rest of the world build around it. That's how a simple steel box became the foundation of the modern global economy. By the way, remember to hit like and subscribe so we can keep making amazing videos for you.